All right, so I'm going to work on Knight-Jones Field, Edition 3, Chapter 9, Problem 13. A small 100-gram cart is moving at 1.2 meters per second on a frictionless track when it collides with a larger 1-kilogram cart at rest. After the collision, the small cart recoils at 0.85 meters per second. What is the speed of the large cart after the collision? So this question, we have a collision between the small cart and the large cart. So that's our system. And I always like to draw a sketch. So before the collision, initially, we have the small cart moving at 1.2 meters per second. So we'll call this cart 1. The mass is 100 grams, so that's 0.1 kilograms, and it's moving at 1.2 meters per second, so I'm going to pick to the right as positive. On a frictionless track, when it collides with the larger 1 kilogram cart at rest, okay, so this is the one that's moving. After the collision, so the collision happens, kaboom, the cart moves backwards at 0.85. So recoils means backwards, and that's in the negative direction. What is the speed of the large cart? So I think it's probably going to the right, so I'm going to put an arrow to the right. What is the speed after the collision? All right, and this is final. So we are sort of doing an accounting of momentum. We know that the momentum should stay the same from before to after the collision. The accounting part is that we need to have a momentum term for each object in the system for each time period, before or after the collision. In this case, we have two objects. So we're going to have the initial momentum of the system is equal to the momentum of the first cart added to the momentum of the second cart before the collision. And we're going to do the same thing after the collision. So the cart 1 after the collision added to the momentum of cart 2 after the collision. And we need to figure these two things out. So that's what we're going to do next. Let's start with the initial. Okay, so the initial momentum is the sum of the momentum of cart 1. So that's going to be the mass of cart 1, which is 0.1 kilograms. Let me just write down momentum in general as mass times velocity. That's the definition. Times plus 1.2 meters per second. And the momentum of cart 2 before the collision is its mass times its velocity, which is 0. So this whole term is 0. So we know the initial momentum is 0.12 kilogram meters per second. Okay, so we've done the before. Now for the after, we need the same two terms, one for the small cart. So that's going to be 0.1 kilograms times the velocity after the collision. It's going to be negative 0.850 meters per second, added to the momentum of cart 2 after the collision. And this is the part where we don't know its final velocity. So I'm going to leave that as a variable. Okay, so we have these two things. Now we're going to set them equal because the momentum of the system before the collision should equal the momentum of the system after. Therefore, the momentum before, we know it, it's 0.12 kilograms meters per second, and that's equal to the momentum afterward, which we know one term of it is minus 0.085 That's equal to minus 0.085 kilograms meters per second. So it's the momentum of the first cart afterwards, plus 1 kilogram times the final velocity of the heavier cart. So we're going to solve for the final velocity of the heavier cart. So we're going to add the final velocity of the light cart to both sides. And that's equal to 1 kilogram times VF. And then we're going to divide both sides by 1 kilogram. I'm going to use my calculator to add those two terms. So 0.12 plus 0.085 is 0.205, all divided by 1.0 kilograms. So the final velocity is 0.205 meters per second, and that is to the right. Okay, so we did it. If we really want to, it's a good idea to go back and check that the initial momentum is really equal to the final momentum. Let me use a different color. So we think that this final velocity is 0.205 meters per second, and we know that the initial momentum was 0.12, so we can check what the final is. So I'm going to go back to this equation. I'm just checking now. So my checking is done in pink. 1.0 kilograms times plus 0.205. So if I add those two things together, I get minus 0.085 plus 0.205, and that adds up to 0.12. And so that does indeed keep our momentum conserved. So we're happy.